In this lecture, you'll learn about the bottom 4 OSI layers, where network engineers are not typically very concerned with the top 3 layers. We are very concerned with the bottom 4 layers. This is really bread and butter stuff for us. Each of these bottom 4 layers are so important that they're going to have their own dedicated section later on in the course. Here, I'm going to focus on giving you the definitions, which you're going to need to know for the exam. So the first of the bottom 4 layers, we'll start with layer 4, which is the transport layer. The main characteristics of this layer are whether TCP or UDP transport is going to be used and the port number. Now, if you don't know anything about TCP or UDP or port numbers already, don't worry about it too much for now, because we're going to be covering this in the dedicated section for layer 4 later. For now, you just need to know that if we want the communication between the two hosts to be reliable, then we'll use TCP. If speed is more important than reliability, like for voice or video traffic, then we'll use UDP instead. The other main characteristic at this layer is the port number. For example, port number 80 for HTTP web traffic, port number 25 for SMTP email. Now, there is quite a lot of other information also in the layer 4 header, but we'll talk about that when we get to that particular section in the course. The definition for layer 4, the transport layer defines services to segment, transfer, and reassemble the data for individual communications between the end devices. It breaks down large files into smaller segments that are less likely to incur transmission problems. The next layer is layer 3, the network layer. The most important information at the network layer is the source and destination IP address. Again, there's a lot of other information also carried in the layer 3 header, but we'll talk about that when we get to the later section. Routers are layer 3 devices. They operate at layer 3 of the OSI model. And the definition of the network layer, it provides connectivity and path selection between two host systems that may be located on geographically separated networks. The network layer is the layer that manages the connectivity of hosts by providing logical addressing. IP addressing is our logical addressing. Next layer is layer 2, the data link layer. The most important information here is the source and destination layer 2 address. Again, just like with layer 3 and 4, there is other information also included in the layer 2 header. For example, the source and destination MAC address if Ethernet is the layer 2 technology. Different layer 2 technologies use different formats for their addressing. For example, old legacy frame relay uses DLCI or DULCI numbers for the addressing. With Ethernet, which is what is always used on our local area networks, it's the MAC address that is used here. And switches operate at layer 2. Our switches are layer 2 aware devices. The definition for the data link layer, it defines how data is formatted for transmission and how access to the physical media is controlled. It also typically includes error detection and correction to ensure a reliable delivery of the data. And finally, we have layer 1, the physical layer. This concerns literally the physical components of the network, for example, the actual physical cables being used. Definition of the physical layer, it enables bit transmission, the ones and O's, between end devices. It defines specifications needed for activating, maintaining, and deactivating the physical link between end devices. For example, voltage levels, physical data rates, maximum transmission distances, and physical connectors, etc. Okay, so there you have it. That was the quick overview and mainly the definition of the bottom 4 layers. As we go through the rest of the course, we'll be covering those in much more detail.